bodies in motion. It is a way, it says here, of combining two or more equations. Now, which equations are you talking about, Ms. Munson? I'm talking about the equations that we already did. And so in Unit 1, we start off with displacement, which is x sub f minus x sub I. Remember that lizard that was on the tree and how it was moving? That's displacement. Or if you have a picture, you would just use a ruler to find the straight line. Velocity and speed are the same equation, d over t. That was easy. And remember that quiz that we just took and we looked at? For an example, the Wonder Woman, we were looking for her acceleration, which is final velocity minus initial velocity divided by time. So from those equations that we've already talked about, we are going to combine them to make new equations. We know that distance, we prefer it to be in meters, and VI, which is our initial velocity, we prefer it also to be in meters per second. VF, final velocity, we prefer it to be in meters per second. But I want to pause real quick after we get to time. If for some reason we are in miles per hour, as long as they're all in the same units, that is completely A-okay. If one of them, for an example, if this one was in hours, we would just need to convert it to seconds, and we would be good. Okay, so if one of them is not like the others, we need to convert it. Acceleration, we prefer it to be in meters per second, but it could be in hours, miles per hour squared. And I don't want us to freak out because some of our units, some of our numbers are given to us in words. From rest means that my initial velocity is 0 because you started from rest. If you come to a stop, then your final velocity is 0. But in our notes on Unit 1, we talked about this part right here. And we said that constant acceleration is completely different from constant velocity. Don't confuse it with constant velocity. Those are two different words, constant acceleration and constant velocity. I said, hey, let's take a glance at this little chart. This first chart over here to the left, 0, 1, 4, 5, 7. My object is accelerating. It's changing its velocity. That's what acceleration is. The chart in the middle, 0, 4, 8, 12, 16. I have constant acceleration. That's what this is. Constant acceleration is this chart. I am not only moving, but I am speeding up at a constant velocity, which gives me this constant acceleration. But chart 3, 2, 2, 2, 2, 2, 2, 2. Am I moving? Yes, I am moving. Am I accelerating? No, I am not accelerating. So we could have a 0 acceleration, but yet still be moving. That's what I wanted to make sure I clarify. One more time. We could be moving and have 0 as our acceleration because we're not accelerating. We have a constant velocity. All righty. Now, this are our equations that we just covered from Unit 1. Now, what we're going to do for Unit 2 is we're going to get those 3 equations and we're going to morph them into what I call the superhero Power Ranger morph equations. So for this situation, we have, yes, they're new, but we're just using what we did before. So we're going to have a new acceleration, which is final velocity squared minus initial velocity squared over 2d. So we're still using the same variables. We just kind of twisted them a little bit. Here's another new one. Displacement equals initial velocity times time plus 1/2 at squared. And then another displacement equals final velocity times time minus 1/2 at squared. The only problem or thing that I want to clarify is that even though we have formula charts, there are a few equations that are missing. This one is a missing one. So the majority of your equations are on the formula chart, yes. But this equation is a missing equation. But no worries, this one is on the formula chart. And it's just like it, except the VI changes to a VF and the addition swaps to a subtraction. So it's a little bit different. Let's turn the page. So when it comes to what we call kinematics, we're trying to solve or do algebra, but in this problems that we're about to come across, we could be missing two variables and still do our algebra with our equations. So step number one, you're going to go through the word problems, and believe me, I will practice them with you, and I'll identify our variables that we have, the variables that were given to us, and the variables that we're missing. Then I'm going to teach you how to choose the correct equation. And then after that, we're going to solve it. The problem with solving is sometimes we forget our PEMDAS. We have to use that, that you learned like in 5th, 6th grade, PEMDAS. Please excuse my dear Aunt Sally. Orders of operation. Okay, there you go. And the only other situation we might come across is that we might have two-step problems where you have to use two different equations to solve for it. Alrighty, so here we go. This are what I call the easy cheesy equations. That was unit 1. No problem. Speed, velocity, acceleration. Miss Munson, I don't have a clue what to do. Well, this flow chart is going to help guide you. Question number 1. Ask yourself, was distance or displacement ever used? And the word distance, displacement, we use that interchangeable, like speed, velocity. We know one means direction. So when you ask yourself, was distance ever used? And if you say no, I promise you, it will be this equation, the easy cheesy acceleration equation. But if you say yes, then you have to ask yourself the second question. Question number 2, was t or was time ever used? Okay? One more time. Was distance or displacement ever used, given, or talked about in the question? No. That is my equation. I'm done. Yes. Ask yourself the second question. Was t ever used? If you say no, time was never given or talked about, well then in that situation, they gave you the VI and they gave you the VF, and you are going to use this equation. I promise you, this flow chart is good. It's like a 98% guarantee. That's the equation that we had from the front page. you're going to use this equation. If t was never given to you, that's going to be the equation. But wait a minute. If t was given to you and they only give you the vi, then you're going to use this equation. D equals vi times t plus 1/2 at squared. There you go. My flow chart is really good. But wait a minute, here is where, remember that one that I told you have to memorize? It's not used very often, but if they only give you the VF and not the VI, then in that situation, D equals VF times T minus 1/2 AT squared. There you go. There's my flow chart. If you ask yourself these questions, my flow chart is about a 98% guarantee. And we're going to practice this so much, you're going to be like, oh, I have that flow chart memorized. All right, turn the page. Now, the problem with students is that I have students that don't follow the orders of operation. And even though they type it into the calculator, they're still going to get the wrong answer because they did not follow PEMDAS, or, please excuse my dear Aunt Sally, the orders of operation. You have to be smarter than your calculator. So let's practice one question, and then that's it for this notes. We'll come back tomorrow, and we're going to practice more. So it says here that a person is pushing a stroller, and they start from rest. VI is 0. Uniformly accelerates at the acceleration of 0.5 meters per second square. What is the velocity after ? VF if the stroller moved a distance of 4.75 meters. All right, so this is physics here. This is what we call kinematic physics. Step number 1, before I do anything, I identified my variables and I'm going to list them. D, T, A, VI, VF. Those are my 5 variables for kinematics. I'm going to list them to help guide me on my flow chart. Distance is 4.75. T, whoa, there's no T here. When there is nothing given to you, I put an X. It's missing. That's what I call a missing variable. A is 0.5. VI is 0. VF is my question mark. So this is how I go through kinematics. I question the variable I'm looking for. I X the question that was, or the variable that was never given to me. So I'm going to go to my flow chart. All right, flow chart. Was D given to me, talked about, or discussed? Yes. So let's go this way. The next question, was T ever talked about, discussed at all? No. This is my equation. Let's just write it down. Let's follow the flow chart. VF squared minus VI squared over 2D. Follow the flow chart and write that equation. Okay? Was D ever talked about, discussed, or given? Yes. Was T ever talked about, discussed, or given? No. T was never talked about, discussed, or even given in the equation. Now we're going to fill in the variables. 0.5 equals VF, right here is my unknown, squared, don't forget to square that, minus 0 squared over 2 times 4.75. Where I see students making mistakes is they allow the calculator to plug it in, and then they don't follow the orders of operation. So, because I